Hey Math 20-1. So we're going to go over still systems of equations, but using them in actual problems. So let's jump into it. So the first one here says a stunned person jumped from a high tower and was in free fall before she opened her parachute. Her height, h meters above the ground, and t seconds after the jump is modeled by these two equations. So system of equations, right? So before the parachute opens, they're accelerating. So it's going to follow that. And then after the parachute opens, it's going to be a constant velocity. So it's going to be that one. So provide a sketch of the scenario. So we can actually we can do this a few different ways. You could do it without putting it in your calculator. But probably the easiest is going to be able to actually put it into your calculator. So, okay, so if you plug the first one in, so f1 of x is equal to negative 4.9 x squared plus x plus 350, you get a line that looks something like that. So probably what's happening here is our scale isn't high enough up. So if you're wondering how we're going to be able to see this thing or get a better view with this is, well, I know I got to, probably nice to go over a bit more to the right, so on the x-axis. And I got to go up higher because I got to be able to see where this thing crosses the y-axis. So I'm going to go into menu, window settings, and my y maximum, I'm going to change that. Well, I know that this first equation, it's 350, right? So I'm actually going to change that to maybe 400. Because if it's 350 on the last one, that's going to be my x-intercept, or my y-intercept. So that's going to show me where it crosses. So y max is going to be 400. And probably, I'd say x max, we'd like to make a bit bigger too. I'm going to make that just around like 40 so we can see a bit more, right? We only see 10 just the side of the screen there right now. So if I do that, there I can see that first graph, right? So if you do, so that's number one. Now we just need to graph one more. So I'm going to push tab, and now it says f2 of x, and I can just put my next equation in. Okay, and there's my new equation. Let's grab the red one and move it up there. Okay. So what we're interested in, so remember it says, so provide a sketch. You guys can go ahead and, well, I'll do the sketch here too. The sketch would look like, well, really like our graph looks here. So you guys can make a sketch of that on your paper. And it says, how many seconds after the stunned person jumped did she open her parachute? So what we're really saying is, when do these two graphs cross? So I need to find the intercept. So I'm going to go menu, analyze graph, and click intersection. Go to the left, go to the right, and according to this, so from this we can see that it's going to happen at x is equal to 7.06, so 7.06 seconds. So part B here, that's going to be at x is equal to 7.06 seconds. Last one says, how high was she when she dropped, or when she opened her parachute? So we can just look at the y value there then, right? So the y value in our graph, whoop, wrong one, was 113. So 113 meters. Okay, so that's it for that one. Make sure you guys make a little sketch there too. Next one says, from the roof of a building that is 50 meters tall, a tennis ball is thrown downward, so from the top of the building, right? So we've got, a person up here throwing a tennis ball downward, so something like that, right? Maybe I'll make that a different color. Let's make that one blue. So top of the building, they throw it down. A tennis ball is thrown downward with an initial speed of 10 meters per second. The height of the tennis ball, h meters above the ground after t seconds, is given by, so there's one of our equations. At the same time, a basketball is thrown upward from the ground with an initial speed of 15 meters per second. The height of the basketball is given by this equation. So there is our equation. So the basketball would look more like this. It's thrown up and then back down again. Says provide a sketch of the scenario. So that's this. Determine the time at which the tennis ball and basketball reach the same height. So again, we're looking for when do they cross? When are they right there? Okay, so in order to solve this one, I put our two equations beside each other. And what we're going to do is I'm not going to actually do it in the calculator. We could. But I'm going to do it by the comparison method. So the comparison method, remember, we're going to make y1 equal to y2. In this case, though, we're talking about like h1 equal to h2. So this would be like h1 and this would be h2. So all we have to do is make these two things equal to each other. So what I mean by that is I'm going to make this equal to this. So that like that one would be on the left side of the equation. This would be on the right side. So I'm going to do that now. So I'll rewrite this as negative 4.9t squared minus 10t plus 50 is equal to negative 4.9t squared plus 15t, and that's it. Okay. So if I rearrange this, something kind of nifty or kind of good happens. If I add 4.9t squared to both sides, they cancel. So those cancel. So our t squareds are gone, and I'm left with minus 10t plus 50 is equal to 15t. I'll bring 10t over here, so plus 10t. And I have 25t is equal to 50, so I'll divide both sides by 25. And I've got t is equal to 2 seconds. Oop, I said 2 and I wrote s. 2 seconds. Okay, so that takes 2 seconds. We solved that algebraically. So B is done. What is the height? Well, we can figure out the height a couple of ways. If I know that this is my value for t, all I got to do is put this back into there, right? So to do that, if you go ahead and do that, I just put 2 in place of that equation, you end up getting 10.4 meters. Okay, so that's the second part. Now, in the original equations, what do the parameters for A, B, and C represent? So what I mean by that is, you know, this was A, that was B, and this was C. What do they represent? So A in this case represents acceleration due to gravity. So that's, you know, gravity. B represents the speed that it was going, the initial speed. Wow, that was really bad writing. That says initial speed. And C was your initial height, right? Because the C is your y-intercept, so that makes sense. So their initial height started from up here for the one that was off the roof. Our initial height for the other one started at 0, so that's their, yeah, okay. So that's that question. Now for the last few questions, I'm going to help you set it up, but I'd like you guys to finish it. So this one says, the number of students attending a leadership conference depends on the price charged. We've done ones like these in other units, right? This should look familiar. It is determined that 20 students will attend the conference if each is charged $75. Okay, so this is one of those revenue questions, right? So it's revenue, our basic equation, is revenue is just going to be equal to the number of students times the price, right? Like that one should be pretty straightforward. Just that's how much money you would make, number of students, and then how much they get for each one. And so far, if we didn't have this, the number of students and the price going up and down, it says that this would just be equal to, so 20 students. I'm going to leave a space here because we're going to change it up a bit. But it would just normally be 20 students and $75. That would be typical, right? But we're going to change the number of students and the price here. So the next part here says from each $10 increase, so the money part of it, so the second one, so $10 increase, so I'm just going to go plus 10, one fewer student will attend. So fewer, I'm going to go minus 1. And now the last thing we're going to do though is I'm going to call x, the number of increases. So I've just written that here. So x is the number of increases. Okay, so now we've pretty much got it, right? If you expanded that, it would look like our normal x squared plus something x plus something at the end, right? So that's one of our equations. So it says create for each scenario. So that's the first one, but we're going to have two of these, right? So the second thing says the cost of running the conference is a rental fee of $1,000 and $75 per student. Okay, so actually, if I go down here, I'm just going to write in red, I'll write that. Okay, and this one in blue. So cost, so we got one for revenue. Cost is going to be a new one. And it's going to be just $1,000 because that's the set price, plus $75 times the number of students. So times x. So that's going to be our second equation. I'll write that as y. Y is equal to 1,000 plus 75x. So now we've got two equations. We've got a system of equations. You can figure out where they intersect. I'll let you guys use whatever method you like from the last topic. All right, I'll help you set this one up too. It says two numbers are related in this way. Double the first number. So I'm just gonna say first number is equal to x, second number is equal to y, just so we kind of keep it like we're used to. So double the first number is 5. So to figure this out, what I'm going to do is I'm going to say double the first number. So 2 times the first number. And that's going to be 5 more than the second number. So the way I kind of like thinking about this is going to be 2x is equal to y plus 5. So now the first number is double the first number is 5 more. That's 5 more than the second number. So that's our first equation. The second one, so that's number 1. The second one we're going to use is the sum, so adding, right? Sum, adding, of the square of the first number. So I'm just even going to write this as we go. So square of the first number, and I'm adding it. So I'm going to go plus. So the sum of the square of the first number and the second number, so just plus the normal second number, is 115. So is equal to 115. So there are your two equations. I'll let you guys go ahead and find the answers for that. Actually, I'll give you the answers for this one. So your solutions for this one actually could be a few. It could be negative 12 and 29 or 10 and 15. So, you know, negative 12 would be your x, that'd be your y, that'd be your x, and that'd be your y. Okay, so there's the answer for that. Make sure, see if you guys can go through and solve for those to get those numbers. Okay, I'm actually going to let you guys do number 5 entirely on your own. It's a little easier than this last one. I just want you to come show me before you move on to the homework questions on my website. And then those homework questions are due for next class. I'll see you guys in class.